Hello and welcome to our last video of Chapter 7, Lecture 17. We're looking at learning objective, let's try that again. Learning objectives 6 and 7. So we're looking at metals, nonmetals, metalloids, and then we're looking at group properties. So looking at properties of all these things. So a metal, those are our things on our left side of our periodic table, and we would say that a metal has something called metallic character. So metallic character is just all the characteristics that we think of a metal. It's going to be talking about the reactivity of the metal, as in it gives up electrons very readily. And then, of course, talking about things like how brilliant and shiny it is, how malleable and ductile, and all the metal properties we think of. So when we think about metallic character, this is also something that has a trend within the periodic table, and our trend is as we go from right to left of our periodic table, we increase in metallic character, and as we go from top to bottom of our periodic table, we increase in metallic character. So looking at our periodic table, let's try and draw that a little bit more to scale. We're going to increase going right to left and increase going top to bottom. And things with a large amount of metallic character are going to have very low Z effectives because we're not holding on to electrons very well, right? So if we're not holding on to electrons, we are able to give them up readily, which makes it a metallic character. Remember that metals are going to be lustrous, they're going to be ductile, have luster, we'll go with luster, ductile, malleable, so can be formed into a wire. It can be manipulated. They are heat and electricity conductors or conductors of electrons. They are going to form metal oxides that are basic. We're going to talk about that a little bit today. And they're going to form cations in solution. And of course, they're going to have low ionization energies. They have low ionization energies, which allow them to form cations. Our nonmetals, these are going to be dull. They're usually various colors. These are silvery, by the way, silvery. There are very few non-silvery metals. Copper is one of them. Copper is a non-silvery metal. But nonmetals are dull, various colors, except for silvery. Brittle. They are going to be poor conductors of both heat and electricity. They are going to form nonmetal oxides that are acidic. So if those oxides are in water, they'll form acidic solutions. They are going to form anions or oxide anions. They're going to have large electron affinity values, large negative electron affinities. They're going to desire electrons. And they usually have large electronegativity values as well. Okay, and then our metalloids. Those are the things that have characteristics between that of a metal and a nonmetal. As a matter of fact, most of them are semiconductors. So they're not conductors, they're not non-conductors, they are semiconductors. So they can kind of conduct electrons and heat. Okay, so as I said, metal oxides, these are going to be basic in nature. So when we dissolve them in water, they're going to increase the hydroxide concentration. So something like sodium oxide, when we throw that in water, will produce sodium hydroxide. So we produce a metal hydroxide. And that metal hydroxide is basic in nature because then it will go on to break down to produce sodium ions and hydroxide ions. So it increases the hydroxide. So what happens is our O2 minus is going to react with water to produce our hydroxide ions. And because these are basic in nature, they will react with a acid to produce salt and water. So we can have something like nickel oxide, nickel 2 oxide, plus nitric acid will produce nickel nitrate, nickel 2 nitrate, and water. Okay, our nonmetals will produce nonmetal oxides that are acidic. So something like carbon dioxide is considered a acidic oxide, acidic nonmetal oxide, and it's acidic because when it reacts with water, it produces an acid. So this is carbonic acid, and that carbonic acid produces H plus ions in solution. And of course, it'll react with a base. So carbon dioxide reacting with sodium hydroxide will produce sodium carbonate, a salt, plus water. So our neutralization reactions from one of our previous chapters, chapter 4, right? Something like that. Okay, next and finally, we're going to talk about group trends. So that's the last part of this chapter. So if we have things in a group, they're all going to have the same number of valence electrons. So members in the same group on the periodic table. So these are columns. they're going to have the same number of valence electrons. And our Z effective doesn't change much going down the periodic table, but we know it changes significantly as we go across the periodic table. So we know that the difference in the number of valence electrons is going to significantly change our Z effective, and it also changes our other properties because everything kind of stems from Z effective. So if we have the same number of valence electrons, we're going to behave very similarly. So we're going to look at a couple different groups. We're going to start with our alkali metals. Alkali metals have S1 as their one electron in their highest shell. So they're going to want to very readily lose that electron, right? So they form +1 cations very easily. So easily that they actually are not found in nature in their metallic form. So to have something like sodium metal or potassium metal or cesium metal, it has to be kept under oil so it doesn't react with oxygen or water. So it is very reactive. They are all very reactive with oxygen and water. They are like the epitome of metallic character. They are soft, so they're very, very malleable, and they are lustrous. Okay? So, oh, I forgot, in elemental form. So you can only find them as compounds. So they're going to lose electrons very easily because they have very high metallic character. Okay, and they're going to become more reactive as you go down the group. I think it kind of rounds off at about rubidium. Rubidium, I think, is the most reactive. But as you go down, your electrons are even further away from the nucleus, so they're even easier to remove. So they are very easy. Those electrons are very easy to remove. They're going to have the lowest first ionization energy of all the metals. So they are explosively reactive with water and oxygen. So they are going to form they'll form oxides in oxygen when they will react violently with water. Okay. When we react alkali metals in air, they can react to form a couple of different species. They can react to form a oxide anion, they can form a peroxide anion, or a superoxide. And if you get a chance, I would suggest looking at your metal anion, your alkali metals in water. It's a fun thing to watch. You can see it in the PowerPoint. I have a video of it. Okay. We can look at our alkaline earth metals next. So these are going to have an S2, so they have a full-filled S subshell, so they are going to be a little less reactive than the alkali metals. They're still fairly reactive, um, but they're just not quite as reactive as the alkali metals are. So they're fairly reactive with water and oxygen. But there are actually a couple of alkali metals or alkaline earth metals that are found in nature. So a little bit different. So a few of the alkaline earth metals are found in their elemental state. But in general, they're going to react with water, they're going to react with oxygen, just like your alkali metals, just less vigorously. And they form +2 ions. So they're going to get rid of both of theirs so they can get down in energy. Okay, hydrogen, we're going to talk about hydrogen real quick because hydrogen is shown in the alkali metals, but it is very different from the alkali metals. So it is not an alkali metal at all. Its chemistry is very different. It has a extremely large I1, first ionization energy. So that is a non-metal characteristic, not a metal characteristic. And it's going to form molecules, it doesn't very easily form ionic compounds. So it does not prefer to form the cation form of itself. And it easily gains electrons just like a nonmetal. Okay, next we're going on to group 6A. So these are called chalcogens. And our chalcogens technically don't include oxygen if we're talking about chalcogens. So we're going to go chalcogens and oxygen. So that's what we're going to be talking about. So as we go down the group, we're going to increase our metallic character. So things like oxygen, sulfur, and selenium are nonmetals. Tellurium is a metalloid, and then polonium is actually a metal. So our nonmetals are oxygen, sulfur, and selenium. Metalloid, tellurium, and then metal, polonium. So we have all three types of materials in this group. The only one that it does not form solid is oxygen. And that's why it is not really part of the chalcogen group. The rest of them are found in ores. And then another neat thing is a lot of them will form different allotropes. So for instance, oxygen and ozone are two allotropes of oxygen, and then sulfur, selenium, and tellurium also form different allotropes. So we got a bunch of different elemental forms for these. Okay, and with this, our ionization energy as we go down is going to go down. Our atomic radius is going to go up as we go down the group. Our density goes up as we go down the group. And in general, our melting point goes up as we go down the group, with the exception of polonium, because polonium is a metal, and metals behave a little differently. Next is our halogen group. Halogen means salt forming. And all of the halogens can be found in salts. So sodium chloride, sodium bromide, magnesium iodide, all sorts of things. So these are going to all be nonmetals, and they're all diatomic. And in this group, we have all three phases. So there is F2 is a gas, Cl2 is a gas, Br2 is a liquid, and then I2 is a solid. These are going to have very large negative electron affinities. And that's because they are one electron away from having a noble gas configuration. So adding that electron in will give them a noble gas electron configuration. They will have a completely full outer shell. So very happy. The reactivity with water is going to decrease as you go down the group. And like I said earlier, they're all going to form salts with metals. Our melting points, obviously, since we're going from a gas to a liquid to solid, are going to increase as we go down the group. Our densities are also going to increase as we go down the group. Our atomic radiuses are going to increase as we go down the group, and our ionization energies are going to decrease as we go down the group. The last thing I want to talk about are our noble gas trends. So obviously, noble gases, from their name, indicate that they are very unreactive. So they are very non-reactive. They don't like to form compounds. They don't like to form any type of molecule. They like to be by themselves. They are all nonmetals, monoatomic in their elemental form, and they are gases. So all of them are gases, all of them are nonmetals, all of them are monatomic in their elemental forms. They have very large I1s. So their first ionization energies are incredibly large because they don't like to react. They are non-reactive. And they have a full-filled outer shell. Because they are fully filled, they don't want to do anything. They don't want to add electrons. They don't want to remove electrons. They are happy. So our noble gases, in general, well, they're going to increase in their boiling point as we go down the group. They're going to increase in their density as we go down the group, increase in the radius as we go down the group, and decrease in our I1, with helium having a very large 2,372 kilojoules per mole ionization energy. Okay, well, that is everything for Chapter 7. I will see you guys later. Bye!